All right, let's go ahead and start talking about rates. So a rate is simply a ratio of two quantities. So it can be any one quantity divided by another quantity. For example, something like miles per hour would be a rate because you have miles divided by hours, okay? Now, on the other hand, a unit rate is a rate that has a denominator of 1. Now, the units are always critical when we're talking about rates because it tells us what we're actually measuring. So it's important to always make sure that we include that throughout our calculations and in our final answer. So let's go ahead and take a look at this example here. It says, given that Taste of the Wild cat food costs $39.30 for 15 pounds and $14.99 for 6 pounds, we want to write each as a unit rate and determine which is the best value. Okay, so let's start with the $39.30 for 15 pounds, okay? So we want to write this as a unit rate. Now, basically all that means is we want to divide, okay? A rate is just a ratio of two quantities. So if we divide this, 39.30 divided by 15 pounds, okay? A unit rate, on the other hand, though, we have to have a 1 in the denominator, okay? Which means we don't want to leave the 15 pounds down there, but instead we actually want to go through and do this calculation. So if you guys pull out your calculators, I'm just going to plug in 39.3 divided by 15, and I got 2.62. Okay, now our units here, we have dollars in the numerator, divided by pounds. Remember what I said a minute ago, division always translates to the word per. So this would be $2.62 per pound, okay? And the reason why this is a unit right now is because we're left with just 1 pound in the denominator, okay? All right, so the 15-pound bag of cat food is $2.62 per pound. Okay. Now, in order to compare that to the 6-pound bag, we're going to do the same thing. We're going to convert it to a unit rate. So again, we're just going to divide. So 14.99 divided by 6 pounds. All right, so again, to get this as a unit rate, I'm just going to plug into my calculator 14.99 divided by 6. And this is going to be $2, and so I have 2.498, so that would round to $2.50 per pound. Okay. All right, so it said in the original question, write each as a unit rate and determine which is the best value. Well, for the best value, we're looking for the one that has the lowest cost, and our second one here, $2.50 per pound, is the lower of the two, so this is going to be our best value. Okay, and I'm going to go ahead and just write this in a sentence. So the best value is the 6-pound bag for $14.99. Okay, that's the idea of a unit rate. Okay. All right, another rate that you guys have probably seen before that you've talked about in a prior algebra class is the idea of slope. Okay, so just to remind you, the slope of a line, you're always talking about the rise over the run. Okay. Another way to think about this is the change in y divided by the change in x. Remember that little triangle? You've probably seen that before. That's the lowercase or uppercase, I think actually, Greek letter delta, and it just means change in mathematics. Okay. Now, if you're talking specifically about 2 points, change in y over change in x translates to y2 minus y1 over x2 minus x1. And that would be, let me just draw you a little graph right here. So if we have 2 points, say x1 and x2, y1 and y2, okay, the slope of your line here is the change in y over the change in x. So change in y is just y2 minus y1. Change in x is, what did I just write? I just wrote something crazy there, guys. All right, my first point would be x1, y1. My second point would be x2, y2. Completely wrote that wrong. Sorry about that. So again, our change in y over change in x. So our change in y is the difference of the y's, y2 minus y1, and our change in x is the difference of the x's, x2 minus x1. Okay. All right, so what we want to do in this next example is to find the slope of the line that passes through the 2 points, 3, 7, and 9, 32. So we can label these points as x1, y1, and x2, y2. Okay, so if we're using our formula for slope, y2 minus y1 in the numerator would be 32 minus 7. And then x2 minus x1 in the denominator would be 9 minus 3. Okay, all right, so then we just need to simplify this. So 32 minus 7 gives us 25. And then 9 minus 3 gives us 6. Okay. Typically, slope we're going to want to leave as a fraction instead of converting to a decimal because that gives us information about the rise and the run when it's in fraction form like this. Now, if we can, you would want to reduce the fraction, but 25 over 6 specifically can't be reduced, so that's just going to be our final answer for this. Okay. All right, let's go ahead and look at another example. So our next one gives us a table of values. We have year numbers of 0, 4, and 8, and then we have a value of a house, 275,000, 297,000, and 319,000 in those respective years. And it asks us to find the slope of the following table of data. Okay, now we have 3 points here, but in order to find the slope of a line, you just need 2 points. So I'm just going to pick out 2 points in this table. Doesn't really matter which ones I pick. I'll just go with the first and the second. So I'll say 0 is my x1, 275,000 is my y1, 4 is my x2, and 295,000 is my y2. Okay. So if we want to find the slope of our line, slope is just change in y over change in x. So we would have 297,000 minus 275,000 divided by 4 minus 0. Okay. All right, so let's simplify this. So 297,000 minus 275,000 gives me 22,000. And then that's divided by 4. And if we reduce that, 22,000 divided by 4 is 5,500. Now, like I said, it can often be helpful when thinking about slope to leave it as a fraction. So 5,500 you could also write as 5,500 divided by an understood 1. Okay. All right, now let's think about the units on this for a second because it's always helpful to think about the units whenever you're finding any sort of rate. So for this one, our numerator was the value of the house in dollars. I'll just add my dollars up there. And the denominator was looking at years. Okay, so our slope here then is a measurement of dollars from the numerator. Remember, the division translates to the word per, and then years in the denominator. So our slope is $5,500 per year. Okay. Now, if we think about what this is talking about, let's try and put this in a sentence if we can. So remember, our x is measuring the number of years, and y is measuring the value of a house. Because we came out with a slope that's positive, that means that we have an increase in the value of the house over time. And specifically, the value of the house is increasing by $5,500 per year. All right, so I'm just going to put that in a complete sentence. So the value of the house is increasing $5,500 per year. Okay.